All right. So I love that guy. He's so entertaining to listen to. But I hope you watched the whole thing because it really helps you kind of get a picture of how these diodes work. So one of the purposes of using diode is in high voltage spike protection. When you have a magnetic field, what forms when it collapses? AC voltage, right? And we talked about how AC voltage is the thing that gives you the wonderful engine noise singing through your stereo speakers, or the pop when a relay disengages, and things like that. So we put a diode in the windings, across the windings for a relay, and it's in reverse bias. And what happens is that AC voltage gets trapped in a circle until it winds itself down. So it's not allowed to go out into the circuit. Every relay you look at has a component across those contacts that's exactly for that. So if you look at these, here's examples. So if you look at an air conditioning compressor, they usually have a diode directly across those. If you look right there, directly across the two wires going to the magnetic clutch. And if you look, that diode is in reverse bias, right? The green wire is power, the black wire is ground, and notice the positioning of it. It's actually in reverse bias. If you look over here below that picture, you'll see a fuel injector and the ECU, right? The computer. And you'll see there's a transistor that's controlling the ground to that particular fuel injector. And you'll see that there is a Zener diode in reverse bias on that pathway to ground, right? And that kiboshes the AC that's created when that fuel injector is powered on and off. And then once again, you look at this relay that's on the right side, and you'll see that diode again in reverse polarity across the windings, right? So it's pretty cool, right? So LEDs, right? We have a anode and a cathode. The LED is a diode, every sense of the matter, except when current runs through, it gives us light, right? So you'll see the anode. Remember, the anode is the positive, the cathode is the negative. If you look at the diagram under the picture of the LED, you'll see that image, and that shows the diode in the direction of the current flow, and you'll see that it is in regular bias, and the little arrows indicate it's a light emitting diode. If you look down at this illustration, you'll see the P type is connected to the positive, the N type is connected to the negative, and when you have both, the electrons, the extra electrons on the N side flow into the P type, and that gives us our light, right? If you take this thing and you hook it in backwards, it doesn't light. If you look on the right side, you have photodiodes. So notice the light flows into the diode, right? That's like the components that give you automatic headlights, or light load sensors for your climate control or your dash illumination, right? You have photoresistors, right? You have at the top, right? That gives you one level of signal, and the one below has a variable component to it. So if you notice the arrows, either the light's coming into it or it's coming out of it. If you shine a heavy flashlight into a LED, you will get voltage out the other side. It's a two-way street, right? Thermistors, which are temperature sensors, right? You all did that in 123 with cooling temperature sensors, right? You have negative temperature coefficient and positive temperature coefficient. Inside that is P and N components that allow that electron movement to give us our change in value coming out the other side. Transistors is the next stuff that we're going to get into next week. They're just like a relay, but better. No moving parts, right? They can switch very quick with duty cycle. They control high current with a low current, just the same way a relay does. And you end up with the P's and the N's in there. So look at notice on the right side, look at the NPN and the PNP, right? You have a certain relationship that goes there, and notice the little arrow that's inside, right? So your low current side, and I'm going to supply you with a picture that really explains this even better. The low current side is 85 to 86 on a relay, and that is the base to the emitter on a transistor, okay? So the base to the emitter, that means that this is one polarity and this is the other polarity. 85 and 86 are the low current windings. We have that same thing that's here. The high current side on a relay is 30 to 87. And on the transistor, that's the collector to the emitter. So when this is opposite of this, what's on this flows out of that, right? So if the base is ground and this becomes power, when that both becomes this power flows out the collector, right? So the purpose of this is it's an electrical switch for a circuit. It acts as an amplifier of current in a circuit, and it regulates the current in a circuit, right? So it's kind of neat. I'll go into this greater when we are going to do our experiments next week for this, right? So that is a little rundown. You're going to find your experiments. I expect you to carry those experiments. I'm going to look straight at you. Carry those experiments to completion. Being that I'm doing them for you, I expect you to read all the material and be able to understand what's going on in it. The only way you're getting credit is if you carry this to completion and get the right information to you. I'm going to work with you, but you have to take it there. Okay? Talk to you soon.